All right, this problem looks like the last, but the difference is that here we have a y squared and just a singlet y. So what we need to do here is get rid of our x squared so that we can solve for y first. We're not going to multiply through by a y and create y squareds and x squared y's. That doesn't make any sense here. So what I'm going to do is go ahead and multiply the bottom line here by -1. So my original equation is going to stay the same. And my bottom equation here is going to end up -x squared minus 3y equals -6. And just remember to carry that all the way through. And then our x squareds are going to cancel. They're the only ones we can cancel here. We can't cancel the y's since they're not the same, since they don't have the same exponent. When I write this out, I'm just going to write out y squared minus 3y, since I can't combine those terms, equals positive 10. And then I can bring my 10 over and factor to solve. So 2 multiples of 10 that add to -3, or -10 that adds to -3, are -5 and positive 2. And that means that y equals 5 and y equals -2. So you have to be careful when you're plugging these back in, because we're plugging in for y now and not for x. And that's not really what comes the most natural to us. I'm going to plug back in for that singlet y. So I'm going to go back to this equation and use it to plug in. So x squared plus 3y equals 6. All right, 3 times 5 is 15. When you subtract that 15 over, you're going to end up with -9. Now, all of the solutions we're looking for are real solutions. So if we get a -9 there, and we take the square root, we're going to get an imaginary number. And when we're finding the intersections of functions, we want points that we can graph on the normal coordinate plane. So that's not going to work for us. That's not going to give us a real solution. Over here on this other side, 3 times -2 is -6. We're going to add our 6 over. Square root of 12, plus and minus, when we force that square root. So 12 we can break down to 4 and 3. And square root of 4 is 2, so 2 radical 3. So that's not a nice integer answer, but it is a solution that we could graph on the coordinate plane. So when we write out these ordered pairs, we have to be careful, because we just put in y to get out x. So our x always goes first in our ordered pair, and that's a really easy thing to mix up when you're writing your final answer. It's really easy to mix those up if you put in y to get out x. I definitely have been known to do that. So be careful with that. All right, there you go.